Hi there, I'm Han. This is just another video of me solving random equal problem. So today we have a word pattern. So given a pattern in the string S, phi if S follow the same pattern, right? So if we have a B, B, A, first of all the word in S are separated by a single space, right? So we can split it up into four words, right? So we can keep track of the word we have visited, right? So A is mapped to dog, and B is mapped to cat, right? We'll look at the third letter here, right? Um, B is already in the hash map, right? So we can see if the mapping, which is the cat, is equal to the word we're looking at, right? They are equal. So we move on to the last one. Right? A is already in the map. The mapping is the dog, right? Which is matching what we are looking at here. Right? So we return true here, right? Here we return false because dog and fish both map to the pattern A, which doesn't make sense, right? Okay. So we can just iterate through them and then keep comparing if they already in the map, right? If they haven't mapped yet, haven't been in the map yet, we can like map them, right? We can map A to the dog and dog to A. So there's two edge case, right? The length of them are different, right? If we have A, B, B, A, and then dog, cat, and cat, right? So which means we don't even have to bother to compare because they have different lengths, right? We are not guarantee that they have the same length, right? So we need to check for that. So that is the first edge case. The second edge case is that if we have four dog, right? Right. So they have the same length, four word. The number of word is the same as the number of letter in the pattern, right? Where A is mapped to dog, but like B is also mapped to dog, right? This doesn't make any sense. So when we map, we not only that we need to map like A to dog, right? But we also need to map like dog to A. Right? If either one violate, right? So if A is mapping to dog, right, and dog is mapped to A, when we look at B, right? Uh, B is not yet B is not yet in the first map, but the dog here, right, is already in the map, and it is mapping to A, right? But this letter is D, so we can return false. Okay, so so we map two ways, first of all, and the second thing is that we have to check for the length, right? So if the pattern of length is different as the length, you can just go ahead and return false, right? And we need to, before we compare the length, we need to split S, right, by the state, so it can compare directly correctly. Okay, and we need to map, so we call it p map, right, for the pattern map, right? And then S map for the string map. So we need to iterate through the pattern. Yeah, because we know that they have the same length now, right? The same number of words and the same number of letters in the pattern, so we can iterate over either one. Like doesn't really matter. Okay, so we have current pattern, right, equal to pattern of I. We have current word, right, equal to f of I. Okay, so if p map, right, the pattern has the pattern, right? So if the current pattern is already in the map and the current mapping, the current pattern mapping is different, right? It's different than the current word, which is the current word, right? Current word, we can just return false here. Right? And similarly, um, if the string, right, if the current word is already in the map, right, and the mapping of the word of the current word is not equal to the current pattern, right? We can just go ahead and return false. And if they are matching, we can just set, right? We can just set the mapping between them. So p map dot set current pattern to the current word, right? and the word.map as map, set the current word to the current pattern, right? And if everything is matching, we can return true again. All right. And thank you for watching.